So again, we are taking the same example that the weights of apples from an orchard show a normal distribution with mean of 6.576 ounces and a standard deviation of 0.312 ounces. Okay. Now say these apples are filled in different bags, each bag containing 10 apples, and we can assume that, and suppose we can assume that each bag of 10 apples is a simple random sample of size 10 from population of all apples from this orchard. Okay, then we would like to know, what percentage of these bags would actually weigh less than 4 pounds. Now this 4 pounds is the total weight of the bag. So there are 16 apples in each bag. There are 16 ounces in a pound, and there are 10 apples in each bag. So the average is how much? 6.4 ounces, right? Okay. So we would like to know that what percentage of apples will have average weight of less than 6.4. So we know this, that if we take simple random samples from a normal population, okay, and we look at the distribution of the sample means, then the sample means will have the same mean as that of the population mean, but the standard deviation would be what? The standard deviation would reduce by a factor of square root of sample size. In this case, it would be 0.312 over a square root of 10 ounces. So that will change. So now all that we have to do is we can go to our TI calculator, because that's what we are using right now, and we will go to normal distribution. All right, and then we are going to select the normal CDF. All right, for the lower weight, let's enter 0. Okay, and I'm going to visit that point in a few moments. And the weight is how much? The mean is 6.576, and the standard deviation is 0.312 over the square root of the sample size. Okay, so what do we get is we get our answer as 0.03722, right? That is about 3.7% of the bags will less than how much? 4 pounds. Okay. Now note that here you entered the lower value as 0, because you can see this is the distribution for the weights of individual apples, and then the sample means will have a narrower distribution, and you can see that by the time you get to 0 on the left, the tail almost diminishes, right? But often what will happen is that you will have a normal distribution in which negative values will also be possible. So ideally speaking, for the lower, you may put negative 10 to the 99, the lowest negative value that the calculator can handle. All right, and if you do that, you will still get the same answer in this case, because both of them are normal distribution, and in this case 0 was far left, far to the left. Okay, so just I thought I would give you this word of caution.